Hi, this is Dr. Francesco again. This is for problem set number 3. And in this section of the course, we're looking at cost. And there's different, so I'm going to go over, instead of going over a lot of the numerical part, I just want to kind of show you where the formulas come from. So once you have the formulas, just plugging the numbers in is not the hardest part. So this is the equation that you have, right? And we're really looking at cost functions. And cost functions are really, in economics, they're standard. So they may look a little bit different in real life, but this is sort of a normal cost function. So in other words, you're going to have an average cost line. It's typically going to look like this. And so over here we're measuring cost, and over here we're measuring quantity. And usually I use little q's. Little q's are to represent a firm, and big q's represent an industry. So when you look at the industry output, you should see a big Q. When you look at a firm's output, you should see a little q. So in this case, we're looking at a firm, because it's a little q. And we're saying that a firm, this firm, like most firms, when they first start producing, they're going to have pretty high unit costs. So if they produce a low amount over here, let's just say they're first start producing their goods, like for instance, Tesla right now, produces, if they produce 70,000 cars, like I think they did last year, then it's gone way up. But when they produce here, their average cost per car is very high, and that's why you're going to see a company like Ford that produces, 7 million cars. Their costs are going to be lower, right? So if you look at the typical company when they first start producing, they're going to have a higher average cost per unit, mainly because their fixed costs are so high that they have to absorb those, and the more units that you produce, the lower your average fixed cost per unit is, so those fixed costs get spread across more and more units. So that's why Ford can produce a car for cheaper than Tesla, and Tesla's got all that, they spread out their technology costs across more. For Ford, they have more units sold and all that. So the typical average cost curve is going to be like this. And then every firm is going to hit this sort of low minimum point here. And at that point here, where this thing bottoms out, that's the minimum average cost. So if you want to find the minimum average cost curve, then the minimum point of the average cost curve, you take the total cost curve, and you say, all right, well, what's the average cost? So take total cost and divide it by Q, and that gives you, or in this case, little q, and that gives you the average cost. And to get, so just take this, divide by Q, and of course that, you could do that mathematically, pretty straightforward. And then you say, all right, well, now that I have this average cost curve, where am I going to find the minimum? Well, the minimum, again, is going to be the derivative of this line when the slope of the line is equal to 0. You're going to find that point right there. So you take the derivative of the average cost curve with respect to little q, set it equal to 0, and what you're going to end up with is finding that point right there. Okay, so that tells you the minimum of the average cost curve. Now, what about marginal cost? Well, marginal cost will come in right here, and marginal cost curve simply looks like that, and it always comes in here, and it will always hit the minimum cost curve at the average cost curve will be intersected by the marginal cost curve at the average cost curve's minimum. So if you're looking for the minimum point of the average cost curve, you can just say, okay, well, let's use this formula right there. Or you can say, well, it's the point where MC, right, that's MC, where MC is equal to AC. There's only one point where MC and AC are equal, and that's the minimum point to the average cost curve. And so this is where costs are minimized. This point is also, this is also the point that in a competitive industry, a company is going to charge in the long run, they're going to charge a price that is the lowest price they could charge in the long run would be right here. So if you look at, if they charge up here, for instance, a higher price, they charge that price, then there's going to be some profit. Okay, so there'll be a profit area. And in a competitive industry, so this is be the price or the demand curve, also margin revenue line or the demand line. Okay, so if the company, if there's profit, then more companies will enter into the industry. More companies will enter and enter and enter and enter. But in the long run, the price cannot go any lower than that. That's the lowest price they can charge in the long run. So if we're trying to find out the price charged, then you need a demand curve. Remember from the last problem sense, we have some sort of demand curve where Q is equal to, we'll just say 100 minus 5p. That would be something that a demand curve would look like, all right? So once we can get the Q, we'll solve for the Q here when we do these equations. You find your Q, you plug your Q into this, and then you find the price. Okay, so your price is going to be set by finding this Q here. You can find the lowest price is here. So price, lowest price available, price company can charge, is going to be where, oops, my writing is really bad, but it's going to be where the price is equal to the marginal cost, and it's also equal to the average cost. So those are the things you're looking for. Those are the cues that you're looking for to be able to solve problem set number 3. And there's some examples up and that you can look at as well in terms of how to minimize costs and to find the cost minimization point, and everything basically revolves around that one point right there. Good luck on problem set 3.